Hi everyone, welcome back to my YouTube channel. This video is going to be part of the series where we are solving lead code medium to hard problem, discuss the problem solving approach we take, the programming nuances, and the complexity analysis of the problem itself. Right. So in this video, I'm bringing you a lead code problem, problem number 658, and the problem is about finding k closest elements in a sorted array. So stay tuned and see how you can go about solving this problem. Let's proceed with the problem statement. As you can see on the left of my screen, uh, it says given a sorted integer array, and you have given two integers k and x. You need to return k closest integers to x in the given sorted array, and the results should also be in sorted and ascending order, right? So an integer a is closer to x than an integer b. I mean, between a and b, the one that's closer to x is if the absolute value of the difference of a and x is strictly less than absolute value of the difference b and x. And in case if the difference is same, then the one which is smaller between a and b is going to be pronounced as the value that's closer to x. So that's what the problem constraint is. So you're given a sorted array, you are given the total number of items to find that are closer to a specified target value x, right? So let's see how we can solve this problem. We can take a given example. The first example, as you can see on the left of the screen, if you take this array, and I'm in line number 2, and I will explain you, putting some comment in the code block itself. Let's say this is the given array, and our x is 3, and we need to find 4 items in this array that are close to 3. So the so if you see, the distance between 1 and 3 is minus 2, right? Distance between 2 and 3 is minus sorry, that's, let's not say minus 2, that's like 2. Distance between 2 and 3 is 1. Distance between 3 and 3 is 0. Distance between 4 and 3 is again 1. And distance between 5 and 3 is again 2, right? So with this, we need to find 4 smallest item. So precisely 1, 0, 1, and between the two that are same value, as specified in the second constraint, the one that's I'm highlighting on the left of the screen. So this distance 2 is coming from a value 1, and this distance 2 is coming from value 5. Right? Since that 1 is smaller than 5, we're going to pick this difference yielded by this value 1. So the output array, what's coming up based on this analysis is 1, 2, 3, and 4, which is like the first 4 value in this hypothetical imaginary array that we created, doing the delta of the target value with each element in the array, right? So this is what we need to do. But given that our array is sorted, do we need to like compute delta for every items, sort that hypothetical or imaginary array, and then find k items from that sorted array? Do we need to do that, or like there's some better way that you can take here? And apparently, since that the array is sorted, there's a specific technique called binary search that you can use here to solve this problem efficiently, right? So let's see how we can do that. So first of all, you are given an array, right? And then you are given a target value x. If we could split this array into two halves, left array and right array, then if we could split this array into two halves, left array and right array, such that all the items in the left array uh, and all the items in the right array is strictly, if you could do that, then what can happen here is the items that are closer to x, right, that hovers, uh, those k items hover between the rear end of the left array and the front end of the right array, right? So the back end of the left and front end of the right is going to give you those k items, right? It can all be skewed on the right array, on the rear end, or it can all be skewed on the left array on the tail end. Or if it is divided, then it's going to be continuous continuation of the rear end of the left array as well as the front end of the right array. So what we need to do is we need to find this split point, right? So in this case, in this example, 1, 2, 3, 4, and 5, right? How can we split this array into left and right array? So the left array is going to be 1, 2, 3, and 1, 2, and 3, and the right array is going to be 4 and 5, right? And the result, what we are going to get is 1, 2, 3, and 4, right? You see, like the continuous stream here, as well as uh, the entire right array, the entire left array, as well as a portion of the front end of uh, the entire left array, as well as a portion of the front end of the right array. So that's what it is: 1, 2, 3, and 4. Right. So how can we find this split point? So if you could find this split point, we just need to traverse in the direction we just need to traverse the left array towards left and right array towards right, and we need a merger of these two traversals collecting k items that are closer to x. Given that it's sorted, the items that's closer to the split point is obviously going to closer than other items in left and right array respectively. So given that this array is sorted, uh, finding the split point is finding the split point, we can take an approach called binary search, where you can divide the array, right, such that all the items on the left is going to be less than or smaller than x, and everything on the right is going to be greater than x. So let's see how we can do that, right? When we talk about binary search, let's park the details of this problem here, and let's focus our attention on binary search so that we transform an approach of binary search to this specific problem, right? So let's say we have a sorted stream of data, or we have a sorted array, right? Sorted data, some array A. So what we want to do here is, let's transform this array into a new array, such that applying every items in that array to a predicate yielding us a boolean value, true or false. So if you could do this in a fashion such that all the false item is clustered on one side and all the true item is clustered on other side, our problem breaks down in finding an index where the last false index is, or where the first true index is, right? So let's say we have an array A from 0 to, like, let's say 10. There are 10 items here, right? So if we could transform this array with some predicate such that for first few items we get false value, and for last remaining items we get only true values, then whatever the nature of the problem, right, uh, doing a binary search will eventually reduce down to finding the index where the last false value is, or finding the index where the first true value is, right? So in this case, what we want to do, our left array has all items equals to x, and right array has right. So if you could have a predicate such that if you could have a predicate such that if you could have a predicate that takes some items p, and it reports that this p is less than or greater than x, then this specific predicate we can use for this specific problem, right? If we apply this predicate in our array, then what is going to happen? Since that this array is sorted, all the items less than or equals to x, that's going to yield us false, right? So it yields us false up until it adjusts all the data that are smaller than or equals to x. Now, from a point where an item is greater than x, all the items subsequently after that are going to be further bigger than previous number. So everything onwards till the end is going to yield us true, right? Now, if you could find the index of the last false where this predicate yields, then that's going to be like a split point, which you can take as a boundary for our left array. And this particular index from the last index to the next index is going to be like the starting boundary for our right sub array. So let's see how we can do that. So I'm going to write a split function that takes an array and the value x, right? So let's have the predicate as I mentioned earlier. If it takes a value p, then it's saying like p is greater than x. It's giving us true if the value that this predicate is taking or consuming is bigger than x. So basically, this holds true for right sub array, and this predicate yields false for all the items in the left sub array. That's how we can split the array into left and right. So now, when we talk about binary search, we are always going to divide and conquer, right? So we are like splitting the array always into half. So let's start array with an initial size where start of the leftmost point is the 0th index and the rightmost point end is like the last index in the array, right? So up until these two pointers don't cross over, what we want to do, we want to take a midpoint and apply the predicate to that midpoint. And so what we should do is apply the predicate to this midpoint of the array. So if this holds true, our goal is to find the last index where false needs to appear. So what we can do here, if this holds true, then we are not much interested in the index that's yielding us true. So we can move the end index to the index that's one unit farther from what this mid is, which can be a potential false index. But at least since that this is true, so we can just move, like we can remove the entire half array from mid till the end, and then make the end as like one adjacently left to what mid is, right? So we can move end as mid minus 1. And otherwise, if this predicate is holding true, then that can be otherwise, if this predicate is holding first, then that can be one of our potential split point for this array. So we don't want to skip this midpoint, but we at least want to skip array and bring the start as close to mid, right? So we don't want to skip this because we want to keep this indexed, because this can be like the potential uh, false last index that give us false in our given array. So with that, what you can do, so once this loop terminates, the start and end overlap or crossover, right? So imagine a case when we don't have any items in the array that are smaller than x or smaller than or equals to x. Then at line number 8, we might end up in a situation where I have all the true, right? And the way how we are designing this split function is we are yielding the last index. We are yielding the last index where this predicate is yielding us false. So if there is no false, then what do we want to do? We just want to return a negative index, indicating that there is no left sub array. That's something what we want to do. Anything other than that, in a case where we have like all false and nothing is true, we can just return the last index n minus 1, right? So which this loop is obviously going to do here. So one last check what's needed here is if predicate test applied to the start, right? What do we want to return here? So if this predicate is holding true, then I want to return -1, because wherever the start has stuck, that's still giving us true. So there is no items in this array that is smaller than or equals to x. That's how we designed our predicate there. Otherwise, we just return start. If you are with me up until this point, I'm proceeding further. If you have any confusion, just pause the video or think it out loud, and you should be able to clarify yourself. Right? So with this, now what we want to do here, let's find the split point, the midpoint, right, where I want to split the array into left and right. Now this mid, so the left array is starting from 0th index up until the mid, right? Now right array is from mid plus 1 up until the last index in the given array. So left boundary is mid, and then right boundary is mid plus 1. Right? So left boundary is mid in a sense. So items from 0, 1, 2 till mid, and right is like from mid plus 1 till n minus 1. So this is like the right subarray. I'm just going to remove this comment. For now, it won't make sense as I proceed with writing code further, but that's what our intuition is going to be for next few lines of coding. Now with this, what I want to do, I just want to collect k items from these two array. Uh, I just want to collect k items from these two arrays. So what I'm trying to do here is, so left is like the tail of the left subarray, and right is like the head of the right subarray, right? So we want to move left further left, and we want to move right further right, collecting k items that are closer to x in this given sorted array. Right? So while k is greater than 0, what do you want to do? So if if left is less than 0, right? So if left is exhausted, then there is nothing that you can consume from the left sub array. Everything can be consumed from right sub array. So this is the case when we can simply update the right sub array, right? And similarly, if this right is greater than, if right cross the rightmost boundary of the array, which is array dot length, what we need to do here, we need to do is like just uh, we need to consume all the items from the left subarray, right, and expand the left boundary, which is like going further left. So this is the case when actually the left array. And this is like the exact opposite and symmetrical case. When we don't have anything in the right subarray, let's consume data from the left subarray because there has to be. Otherwise, this is the case where we are handling if one of the array is exhausted and it doesn't have any more data. Otherwise, both the array had some data, so we need to pick from one or the other, right? And how do we do that, right? So in this case, what we want to do is we will compute like a left delta, right? Like the items that we currently have in the left boundary. Left delta is if we take the left boundary and subtract it with x, right? Similarly, we can compute the right delta here. Now it's very simple. It's like doing a merge in merge sort, but traversing array in opposite direction in two sorted arrays. Right. So if left delta is smaller than right delta, what we need to do, we want to consume items from left subarray because that's closer to x. So we expand the left boundary, right? Else if smaller than right delta is smaller than left delta, what we want to do, we want to expand the right subarray, pick items from there, right? Now, in case if they are equal, what happens? We need to pick the smaller items of the two that both left and right boundary has, right? So else, if if the delta, left delta and right delta are same, but the left boundary value is smaller, then we want to expand the left boundary and pick item from the left subarray. Otherwise, actually, you know what? I think I don't need to write this because the items in the left subarray are obviously smaller than right subarray, right? So if instead of adding that else, if I just do left delta is less than or equals, in case of equality, I'm always expanding the left horizon, right? So if right delta is smaller, it's closer. If right boundary value is closer, then expand the right subarray, otherwise expand left subarray. So that that should be good enough there. So I didn't need else if, I think just an else it's sufficient here. So if left delta is less than or equals to right delta, then expand the uh, left array or left boundary, otherwise expand the right boundary, right? So with this, on each iteration, what do we want to do here? We are picking n item from either left subarray or right subarray and decrementing the k, so that at the end of this loop, we have a boundary between left and right that has k sub that has k entries closest to x. Now all that we need to do is collect these items from the array, put it in a list, and return it as specified in this specification in this function here. So what we need to do, let's create a list of integer, and since that the array is sorted, so now that we have the left and right boundary, right? So at the end of this loop, left boundary is going to be one index further away from where we start picking the item. So I'm starting from left plus one. And so is the right boundary. The last item is one index closer to where our right is being ended, because picking an item, picking the last entry in either left and right is going to expand that index. So we are taking an exclusive subarray between left and right from the original array. And this should just about do it for us. But there's one important concept which I need to get back to. So let me finish the code first. Results, right? Okay. Okay. So now if I run this code, this is accepted, right? But there is one big problem here in this code. This the test cases what's provided here is not covering for a corner case when we have just two items in the array, right? So let's say we devised a binary search algorithm uh, such that we have written a predicate that would give us like a virtual Boolean array where all the false are clustered on the left and all the true are clustered on the right, right? So what if we have an array with two entry such that we end up with Boolean array like false and true? So in this case, our start is going to be 0, our end is going to be 1. So when we compute like mid, that is start plus end divided by 2 is 0. So when we apply predicate, When we apply predicate to this mid value 0, we are getting false, right? So when we are getting false, what will happen? When we are getting false is we put the start back to the mid, right? So our start is 0, end is 1, and again we haven't updated start. That's still stuck in 0, right? So what do we want to do to get rid of this? First of all, I'll just submit the code here, and you'll see what I mean there. Because that's the case when this can stuck in an infinite loop, right? So here, if you see the time limit exceeded, and our array is 1 to 2 entries, k is 1, and then x is 1, right? So when x is 1, uh, okay, when x is 1, so this is again the case where you have like 2 entries. So in order to fix that, what we need to do is let's define mid such that it's not only start plus end divided by 2, but make sure like we have start plus n plus 1 divided by 2, right? So this is always going to alter it. So shuffle things such that we are never going to get stuck in this nuance of infinite loop. So if you now, this can handle all the cases, whatever it is, like false, 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 true, or like true, false. So if you take this plus 1 out and try to see for all scenarios, false and false, and for false and true, right? Uh, and you'll get the answer. All right. Now, if I first of all, let me run it with the change that was accepted. But if I submit it with this change, it is accepted. And the runtime is 46 percentile. The memory is 43 percentile, which is not bad. And just to give you like a glimpse of the entire solution in a single screen, let me zoom out a little bit. So this is the find closest, and this is my split. I hope you like my solution. If you have any suggestion, feedback, please leave that in the comment section. And always, if you haven't subscribed, please press that ring button. And I hope you really have a very nice rest of the day. And as always, live, love, and laugh. Thank you. Bye.